Okay, so in the previous tutorial we have seen how we can add idle brake animations. So if I go to the locomotion graph and idle state machine, so this is the place actually we add those idle brake related state transitions and animation sequences. And now I think we are almost done with this idle animation setup, and then maybe we can add some cycle animation to our project, because I think for now it is just idle character, and even if I try to move it, it simply slide through the ground, which is not quite good. So uh, as as an initiative for the movement animations, let's start implementing some cycle animations, and maybe later on we can implement much more advanced features to the existing locomotion systems, such as start states and end state, maybe even turn in place sort of animations. But for now, let's try to implement cycling animations as a first step. Okay, so now uh, since we're done with our idle animation setup, we can go out of that uh, state machine, and here we are at the entry level. uh, so now what I can do is I can create a new state called cycle, and it has a transition from idle state to cycle, plus whenever the character stop moving, it should go back to cycle state to idle state. Okay, yeah, uh, so first so now since we have a state transition, I think instead of implementing these cycle animations, first we need to make a proper transition. Otherwise this state won't be never reached from this idle state onwards. Okay, so let's see how we can implement it. Yeah, let me quickly look at my implementation. Okay, um yeah, so first we have to detect whether we have a movement or not, right? So we can easily do that by checking the velocity of the character. So obviously the velocity is a positive value, and that's a movement. And if it is not a positive value, then we can uh, safely assume that character is in sort of like a idle state. Okay, so I'll go to this blueprint thread safe update animation function, and here maybe we can create a new function called update velocity data, right? And make sure to make this as thread safe, otherwise you can't use it within this blueprint thread safe update animation function. So make sure to toggle this thread safe tick, and I'll move this function to this blueprint thread safe functions. And yeah, now um yeah, do we have a reference to the velocity? Let me check. No, we don't have a reference. So first I think we should capture uh, the local velocity of the character. um yeah, but let's start from the world velocity, and then we can use it to calculate the local velocity. And by using that local velocity, we can determine whether there is a possible movement or not. um, so we can use this property access node to access our property variable of the character in a thread safe manner. And we can maybe use this try get power noun, and inside this function there's a reference for get velocity. Where is it? Get velocity, and we can promote this to a variable. Maybe I'll name this as world velocity and assign it to a group called maybe world velocity for now. Okay, maybe later on we may need to change this stuff a little bit, but yeah, for now this would be fine. Yeah, so now I captured the world velocity, and most of the time we don't need to consider about the z-axis velocity for a specific character, because if I show you this x and y axis are the ones that we need, basically the forward axis and the right axis that is perpendicular to x, and this up vector, which is z, is not quite required to calculate the world velocity or for the movement related data. Therefore we can cut that vector from this. So the easiest way of discarding that up vector is simply multiply it with a unit vector, which is 1 by 1 by 0. So whatever the z value stored at this variable will be cancelled because we are multiplying it with 0. Now I can promote this to maybe a local variable, because we need this calculation to do within this function only, so I don't need to expose it as a separate variable for the outside. So I'll create a local variable called world velocity 2D. And now we have the world velocity. So there we have to calculate the local velocity of the character. So in order to do that, actually we need to know about the world rotation of this character as well. So in order to do that, I think we need to calculate the rotation in a different instance before the location calculation. So let's create a new function called update rotation data, and I'll move it to here, and let's go to the before moving to there, make sure to tick it this thread safe option as well, and then let's go to the blueprint thread safe update animation, and let's plug that update rotation data function right after the update location data. Okay, now inside this function, all we have to do is simply calculate or simply call the world rotation out of the character. So let's use the property access as usual and get the owning actor and get actor rotation, and I'll promote this to a variable called world rotation and assign it to a category called world rotation. Plug this thing out. Okay, now we have a reference for the world rotation. Now let's go back to the update location update velocity data function, and here Now what we can do is we can use this world velocity 2D vector and unrotate it by using the world rotation reference that we have. So it will return a vector of unrotated vector, and maybe now we can call or store another instance called local velocity 2D. I'll name this as local velocity 2D. Okay, and then we have an unrotated vector which is calculated by using the world velocity. Now now what we have to do is we have to check whether we are moving or not. How can we do that? The easiest way is, since we have this last velocity 2D, for each frame we can check whether this local velocity 2D is 0 or not, right? So these calculations happen for each frame. So whenever this calculation has been happened, after the next frame onwards we can do this checking. So since we have to do it after one iteration, we can do the checking at here. Otherwise each frame will be waiting until this happens, right? So here you can check whether that vector is 0. So this is a quite handy function. It simply check whether all of these xyz values are 0 or not, or even maybe comparing it magnitude. And maybe we can get the inverse of it, and I will promote it to a variable called was moving since last update. Okay, so now we can check whether we were moving since the last update or not. So maybe just for the debugging purposes I can log this string, but I'm not quite sure whether it will log properly or not because it's a threaded function. But yeah, it's log string like this, and now we have to call this function inside our blueprint thread safe update animation right after this update rotation data function has been called. So I will call this one update velocity data, and just for the organization purposes I will change the order of these functions like this, and then yeah, so since we have at this log, I think this should log properly. So I'll clear the log. Yeah, you can see like it's keep printing because even if I haven't run the game, this function is been calling. You can see that here, right? This function is keep calling. So if I try to move, uh yeah, it still says false. Maybe let's check why. Yeah, maybe let's try whether the world velocity is capturing properly. Okay, the log. Yeah, the world velocity is capturing. And then have to check the world velocity 2D is properly captured. Okay, everything. There's an error. World velocity 2D. Okay. Play that thing. Yeah. So it's also capturing. And then we have this last velocity 2D. Local velocity 2D. Let's debug that one as well. Yeah, this also works. So not quite sure why this one is being 0. Being false at every time that we are calling. Yeah. Maybe before the frame, let's call it out. Yeah. I'm not quite sure actually why this one is not calling. So let's, for a moment, let's ignore it, and maybe let's try to implement the anim graph, and that position or not we may able to debug it further. But yeah, let's see. Yeah. So inside this transition, we can now plug this thing. Was moving since last update. And then let's see whether the transition rules are there. Yeah. And then maybe we can go to this cycle animation, and just for now maybe add some cycle animation just for the reference. Maybe jog forward, jog unarmed, jog forward, and let's play. Yeah, I think that is not triggering properly. So let's see why. Yeah, so I think I found the issue. So the issue is at a very tricky thing actually. So we have this local velocity 2D variable here, which has been initialized like a local variable. So ideally what would happen is that for each frame, when this function is getting called, this local velocity 2D, which is a local variable, is getting reset, which is not what really we want to do. Instead of that, we have to capture this in a global variable, and we have to call it in each frame in that shared manner, right? So basically we have to get rid of this local variable, and we have to make it as a global variable. So for that I'll remove this. No, I'll keep this log as well, so it will be easy for us to debug. So I'll make this local velocity 2D uh, as temporary for now. I'll see all the references. Okay, we have two instances to be changed. So I'll start from here. So here maybe we can make this as a global variable or local velocity 2D, and we can plug it to here, right? And then we can get rid of this, and we have one other instance here, and let's replace that using this local velocity 2D, right? And then we can get rid of this local variable, and yeah, now let's try that out. So I'll clear the log and play it again. Okay, now you can see whenever we move, it's become true, right? Which means it is capturing the movement properly. Okay, now we can maybe get rid of this log, and maybe we can organize the code a bit. Maybe we can assign this to world velocity, and let me see. Yeah, maybe we can move this was moving last update to world velocity as well, just for now. Okay, yeah, now we have that ability. So let's go to the anim graph, locomotion, and this is the cycle animation which I have to place, and we have this transition state from idle to cycle, which is here. Now we can set this using was moving since last update, and for the cycle animation, let's add that jog forward animation just for the testing. Let's play this thing. Okay, now you can see the forward animation is playing only once, and it's stuck there. It's not returning to the idle state as well. Okay, maybe we can fix this thing by solving this outgoing transition, which is coming back from cycle state to idle state. So it should be the opposite of was moving since last update. Should be not boolean, and like this. Okay, plus I think at the debugging session I have been renamed this variable for was moving last update. Maybe we can rename it as was moving since last update, so it will be much more meaningful. Okay, now I can move, and yeah, it come back to the idle state. Yeah. Okay, so in order to resolve that only playing once that specific animation sequence, just for the hack, maybe we can make it as a loop animation. So now whenever I play the animation, it's keep playing, which is what we expected. Yeah. So as the initial step of these cycle animations, now we have the initial setup where we can make a proper state transition from idle to cycle and coming back from cycle to idle state, and we can play the animation. But we have to improve this further, for like instead of manually hard coding a specific animation like this, you may have to take different animations based on different directions or different anim sets dynamically by using our data table. So maybe let's see how we can do that in the next tutorial. Thank you.